We will look into a problem from RMO 1994, the Regional Math Olympiad. This is problem number 2. It says that we have a triangle ABC and we draw the incircle of the triangle ABC, and suppose the center of the incircle is I. Now the given data is the following. The inradius small r is equal to 4 units. Moreover, it's given that suppose these 3 points are DEF, then BD, CE and AF. So maybe I can draw that using a different color. BD, CE and AF, they are consecutive integers. For example, they could be like 4, 5, 6. Okay, that's just an example. We want to find out the side lengths of triangle ABC. So our goal, let me write it here, side lengths of triangle ABC. With these two information, that the inradius is 4 and the segments BD, CE and AF are consecutive integers. So we will use this strategy from elementary geometry that relates inradius, that is the radius of the incircle, with area. I will quickly tell you about it so that you can try and apply it in this problem. Suppose we have a triangle ABC, and we have the incircle of the triangle ABC. So all the sides are tangential to this incircle. That's how the incircle is constructed. And the incenter is I. Suppose these 3 points D, E and F are the points of intersection or points of tangency of this circle with these 3 sides. Now ID is the radius. ID is radius and BC is a tangent. So ID is perpendicular to BC, right? So if we look at the triangle BIC, the area of triangle BIC, it is equal to half the inradius, that is ID, the perpendicular in this case, the inradius times BC. The same thing you can do for triangle AIC. So triangle AIC is equals to half IE, which is the inradius, times AC, half R times AC. And finally triangle AIB is equals to half times the inradius, which is R, times AB. So if you add all these three triangles, you'll get the triangle ABC. So just add it up. Triangle ABC, which is the area of triangle ABC, which is the sum of these 3 areas, is equal to half times the radius times the sum of the 3 sides. This is a standard formula, but I just derived it so that if you do not know it from before, you can use it now. So area of triangle ABC is equal to, let's denote it by delta, is equals to half times r times the perimeter. So sometimes half of perimeter is regarded as semi-perimeter, so r times s. Okay, so this is a standard formula that we will be using. There is another formula for area, which is delta, and it's given by s times s minus a, s minus b, s minus c, square root of that. It's sometimes known as the Heron's formula. So we will be using these two formulas of area in the context of this particular triangle and this problem. Let me show you how. So we are given that BD, CE and AF are consecutive integers. I will assume that BD is x minus 1. One of them is larger, one of them is smaller, and one of them is the middle one. So I don't care which one is which. If BD is not the smallest one, we can just reassign these symbols. So assume that BD is the smallest one. Then BD is equal to x minus 1, suppose. C is equals to x and AF is equals to x plus 1. Whenever you have three consecutive integers, it's kind of beneficial to write them in this pattern. Why? Because when you add them up, all the negative 1 and positive 1 cancels off and you are left just with the variable. Okay, note one thing, that if BD is x minus 1, then BF is also x minus 1. Why? Because if B is a point, then BD and BF are both tangents to the circle. So the length of tangents from a given point to a circle are equal. So this is x minus 1, this is x minus 1. Similarly, AE, AF is x plus 1. So AE is also x plus 1. And CE is also x, as is CD. So we have all the three sides of the triangle. Let's quickly compute the semi-perimeter, the small s, which is half the side lengths BC plus CA plus AB, which is half of x minus 1 plus x, this is BC, plus x plus 1, this is CA, plus x plus 1 plus x minus 1, this is AB. So stuff cancels off, minus 1 plus 1 cancels off, plus 1 minus 1 cancels off. So S becomes 3 times x. The semi-perimeter S becomes 3 times x. So what do we know? We know that the area can be computed using this formula. That is half, that is R times S. So let's do that. Delta is equals to, R is 4 because the inradius is given to be 4, and S is 3x. We just computed it. So 12x. So area delta is 12x. Now let's use the Heron's formula here. So this is square root of 3x times 3x minus the first side, 3x minus the second side, times 3x minus the third side. So that's also area. Okay, so let us use this. I'll make some space here. So this is equal to square root of 3x times 3x minus x plus 1 minus x. Then we have 3x times 3x minus x minus x minus 1, and then 3x minus x plus 1 minus x minus 1. So I'm just replacing the value of BC, CA and AB in this formula. So what do we get? We get delta is equal to square root of 3x times x minus 1 times x plus 1 times x. But we already know that this is 12x. So this is equals to 12x. Okay, now we are almost done because we can now just square both sides. So we have 3x squared times x squared minus 1 equals to 144x squared. Cancel the x square. We have 48 if I cancel by 3. So x squared minus 1 is equals to 48. Gives you the value of x as 7. Now can you find out the final values of the length of the sides of this triangle? That's your job. Find it out and put it in the chat. What is the final value of BC, CA and AB if the value of x is 7? It's very simple. It's just one line. Thank you for watching. We will be doing more mathematics in the next video. Take care.